Page 20. Identify linear equations. Or, I'm going to change that word on you, functions. Because we're still kind of working with functions. It all flows together. Identify linear functions. So we've talked about functions, and we talked about when we did functions passed the vertical line test. So when you had a graph, you drew vertical lines through it, and if every vertical line only touched the graph in one spot, it was a function. Let's see, where are those notes? So we've talked about vertical lines. We've talked about what a function is, right? We draw vertical lines through it, so the vertical line test. We've talked about how functions have all different domains. The x values are all different. Now we're getting into very specific types of functions. We're getting into linear functions. And linear functions, by definition, what does linear mean? Yeah, they're graphs make a straight, thank you, line. A linear function, a graph, makes a straight line. And you know me, I'm going to highlight line is in the word linear. So a linear function is a line. It's a graph that makes a straight line. It's a specific type of function. There are functions that are not linear. This is a small subset. Right? This is kind of like science. Inside a group, there are subsets, right? So inside the group of mammals, there are humans, right? Humans are mammals, but not all mammals are humans. Functions can be linear, but not all functions are linear. So we're going to sketch a few quick pictures. They don't have to be beautiful. They're just there to get the process through. So there are my graphs. And on this one, I have this, and this one, I have this, and this one, I have this. So let's talk. Is this picture a function? So let's test it, right? Let's do the vertical line test, right? Is that a function? Yes, it's a function. Is this linear? Yeah. Why is it linear? Well, duh. It makes a straight line. Yes, it's linear. So yes, it's a function, and yes, it's linear. So is it a linear function? Yes, yes. It's a linear function. We can even go a little bit further. If I made this, if I put some marks on it, right? The domain right? The x values in this graph, the domain is from -1, right, to +4. So I can say the domain is from -1 to +4. And I could do the range is 1, 2, 3, 4. -4 is the bottom. And 1, 2, 3, +3 is the top. So yes, it's a function. Yes, it's linear. Here's the domain range. And here's the range. Let's look at this one. Is this a function? Picture number 2. If I draw my vertical line test, yes, it's a function. Is it linear? No, it's not linear. And let's estimate its domain and range again. Again, it's not going to be perfect, but let's say that's -2. Does that sound good? -2. So the +3. And let's do the range. What do you think? -1, -2, -3. Does that sound good? And 1, 2, 3, +3. Again, we're just kind of estimating because it's not a perfect graph. But I know that the x values are between -2 and +3. I know that the y values are between -3 and +3. All right, let's look at this last graph. Is this last picture a function? No. If I do my vertical line test, it's all in the same spot. So no, it's not a function. Is it linear? Yes, it does make a straight line. Let's talk about the domain. What's the x value in here? What do you think? 1, 2, 3. Is there any other value besides 3? So my domain value is 3. Because that's the only place that it hits the x-axis, right? And let's talk about my range value. Well, it's down here, so 1, 2, 3, 4, -4. 1, 2, 3, +3. So the only thing we've added in is this linear aspect. Yes, this one was linear. No, this was not linear. And yes, this one was linear. All we're adding in, the function part's the same, the domain and range are the same. The only new part is whether or not it's linear. And it's pretty easy to tell from a picture if it's linear, right? But we don't want to have to graph every problem we do. I mean, you can, but that's kind of a pain. That takes a lot of work. So if they give you a table, or maybe they give you a relation, so here's a relation, right? How do I know if this is linear? How can I tell if this relation is linear? Well, I could graph it. But I don't want to take the time to draw a graph, plot the points, connect the dots, and figure out if it's linear. There's a much easier way. And that much easier way is to use the common difference. So if they give you a relation, you're going to do the change in x over the change in y. And you're going to have to do it for every single problem. So let's test it. The change in x from 2 to 5, what happens? Plus 3. Now let's check the next change in x. From 5 to 8, what happens? Plus 3. And from 8 to 11, what happens? Plus 3. So that's the same. Let's try the change in y now. From 4 to 3, what happens? Minus 1. From 3 to 2, what happens? Minus 1. And from 2 to 1, what happened? Minus 1. Is the change in x over the change in y the same every time? Yes. If it's the same every time, right? It doesn't change. It's the same every time. Sorry, it's delayed up there. It's linear. Yes, this is linear. Now let's double check. Is it a function? 2, 5, 8, 11. Is it a function? Yes. Why is it a function? Yeah. It doesn't repeat x values. Every x value is different. Okay, let's try a table. If they give it to you in table form, -10, +10. -5, 4. 5, -8, and 10, -10. All right, we're going to do the same thing. The change in y over the change in x. What happens from -10 to -5? +5. What happens from -5 to +5? +10. Don't stop. You have to try it. You have to double check. Do all of the work before you say no. And what happens from 5 to 10? +5. So those are different, but I have to keep going because it may be similar. I may have fractions that can be simplified. What happens from 10 to 4? -6. So my fraction is 5 and -6. What happens from 4 to negative 8? Minus 12. Are these similar? 5 and negative 6 and 10 and negative 12? Yeah, if I divide by 2, I get 5, and if I divide by 2, I get negative 6. So these are the same. What happens from negative 8 to negative 10? Minus 2. Are these the same? No. These are no longer the same. It was okay up until here. This is no, it's not linear. Is it a function? Yes, it's still a function. But it is not a linear function. The last thing that's in this part is something called standard form. I shouldn't say the last thing. It's the last new thing. Besides linear function, it being linear, standard form is new. In standard form is an equation that has x and y on the same side of the equal line. So standard form would look like this: x plus y equals. Now, of course, there are usually coefficients in front of x. It's usually like 3x. So this is called ax, because that's just the coefficient. Maybe it's negative 8x plus by, and b is the coefficient for y, equals c. So for example, 3x plus 8y equals negative 10. That problem is written in standard form. And lots of times in standard form they ask you to identify. They ask you, what is a? Well, a is whatever is with the letter x. A is 3. They're going to ask you, what's b? B is whatever's with y. B is 8. And they're going to ask you what c is, and c is whatever is by itself on the other side. Sometimes you have to move it across. C is negative 10. Write this problem in standard form. Put that in standard form, meaning get the x and the y on the same side and move the constant, the number by itself, to the other side. Standard form is where you have to write x and y on the same side of the equal sign. It could be on this side of the equal sign. It could be on this side of the equal sign. It doesn't matter. You need to move x and y so they're together, and you need to move the constant, the number by itself, What can I move? Corbin, what'd you move?
I moved the 4x.
Okay, you moved the 4x, and how'd you move the 4x?
Add 4x to both sides.
Okay, you added 4x to both sides.
So cancels out the x on the left side and leaves it.
So you have 8 equals 4x minus 16y. And that's perfect. What's the A value? A is 4. What's the B value? Negative 16. Good. And what's the C value? 8. Perfect. I'm going to put this right here and show you the other way. Someone could have done it this way. You could have done 8 minus 4x equals negative 16y. You could have added 16y to both sides. So over here you have 8 minus 4x plus 16y. Right? Then you could have subtracted negative 8, and this is 0. And got negative 4x plus 16y equals negative 8. And I know you say, but these are different numbers. But look, negative, positive, positive, negative, negative, positive. They're exactly opposite, so it's okay. The only other trick is sometimes you're going to see something like x to the over 3. What would that A value be? What would this A value be? 1/3. In order for something to be linear, there are 3 simple rules. You can look at it and say yes or no. You can look at the graphs. Whoa. You can look at the graphs and say yes or no, super easy. You can look at a table or you can look at a relation and do a little bit of math, but it's still pretty easy. If they just give you an equation, you can look at it and know pretty easy. X and Y are not multiplied together. You cannot have X times Y. That's nonlinear. That will not make a line. You can have no exponents. If it has an exponent, it's not linear. And X and Y are not in the denominator. If X or Y are in the equation and they're in the denominator, they're down here, it's not linear. The absolute value of anything is not linear. And the square root of anything is not linear. It's got to be pretty basic. X and Y are not multiplied together. No exponents. X and Y cannot be in the denominator if it's an absolute value or if it's a square root. These things automatically kick it out. If I give you a formula and it has one of these things, not linear.